So where did we get started in this whole business? We got started through a thing called glutathione. Now, glutathione may be familiar to some of you. It's the brain's primary antioxidant. And about 15 years ago, I read this paper that said there's a dramatic reduction in glutathione in people with schizophrenia. And we thought, gee, this is interesting. And the reason it's interesting is because there's stuff that fixes it. And that's N-acetylcysteine. This increases glutathione. So I'm not going to show you the original study that got us interested. I'm going to show you a little bit more recent study, which is post-mortem brain. So this is glutathione, total glutathione, reduced, oxidized, and the ratio. And you can see in schizophrenia, major depression, bipolar disorder, there's reduced glutathione in pretty much all these major psychiatric disorders, which is kind of interesting. So when we read this for the first time, we thought, hell, this is new. This is interesting. I didn't know this. Maybe this is something useful. But the truth of the matter is, there's nothing new under the sun. And then we dug this out, and I love this paper. So just focusing on the date, 1934. So this paper came out in 1934. We've known for almost 100 years that there's reduced glutathione in people with schizophrenia. The second thing that they found in this study, which again, completely ignored and is only being reinvented now as a target for novel therapies, and I'll show you this too, is they found increased lactic acid. So what is lactic acid? Lactic acid is when you've run too fast. In other words, you've gone from aerobic to anaerobic respiration, from to glycolytic generation of energy. Your mitochondrial energy generation is inefficient, and you're producing lactic acid. And this is happening in people with schizophrenia. So essentially what these guys found is that not only do you have oxidative stress, but you actually have mitochondrial dysfunction in schizophrenia. 100 years ago we knew this, and it's taken 100 years before we've actually been able to do anything about it, which is why I think you ignore history at your peril. So not only do you have oxidative stress, and so oxidative stress, redox signaling is another word for oxidative biology. So oxidative stress alters your epigenetic signaling. So this again talks to what Ajit told you about earlier. So if you've got oxidative stress, it alters the expression of genetics. So this can alter DNA methylation. It can change the way that genes are transcribed, and this can alter the way that proteins are expressed. So we're now beginning to understand that oxidative stress, which can occur in childhood, can alter your epigenetic signature and alter the way that the proteins that your body produces are expressed. So this is a way, again, as Ajit beautifully explained, how stress in childhood can, in a long-term way, alter your vulnerability to developing illnesses later.